you have a very fundamental, deep responsibility about what you're telling the universe. Because remember, it's a feedback. So whatever you tell the universe will manifest for you. You are evidence. Your life, every breath you take, everything you do is evidence that the universe can move towards order. Everything you've done in your life has been an increase in information, right? Hopefully, you've been growing, you've been learning, you've been changing, and an increase in organization. So let's start with this from the Connected Universe. This was a movie that was done about my work. It's narrated by Captain Picard. And it talks about that little piece, and I just wanted to show you this so we can get numbers about this, so that it's not just a concept, but that your cognitive mind can understand what the numbers look like.
Is the universe random? Think of the amazing biodiversity of our planet, of all the living things. We live in a wondrous world. Think of the complexity of a chimpanzee. Consider a jellyfish, or a blade of grass. Or something less complex, something not alive, a simple Rubik's Cube. 3 rows, 3 columns, 3 deep, with 6 colors. What is the mathematical probability of solving that by random chance? 13.8 billion years is the current estimate of the age of the universe. If you could send a blind person back in time with a scrambled Rubik's Cube, and they could make one move every second, how long do you think it would take them to solve it?
So you've given a Rubik's Cube to a blind person. It's not very nice, okay? But you've asked him to order it, and the blind person is making a move every second, and now you're going to calculate the probability of that person ordering that cube randomly.
In the 13.8 billion years of the existence of our universe, you would have less than a 1% chance of solving it. So how much longer would it take to ensure that you would solve it? There are 43 quintillion possible states for the Rubik's Cube. To move through every possible state without ever repeating the same one, it would take 1.4 trillion years. And you would have possibly solved it at some point.
That is vastly longer than the beginning of the universe as we see it.
But it could have taken billions and billions of years longer than the existence of our universe to solve a simple Rubik's Cube by random chance. Now imagine the incredible complexity of a human being with 100 trillion cells that are communicating every millisecond to ensure all systems are go. Imagine all the moving parts, all the possibilities. How long would it take to organize that? Because we are so vastly more complex than a Rubik's Cube. Yet humanity exists. So how can this be possible? What if we could tell the blind person something?
If we give just one little piece of information, yes, you're going towards the solution, or no, you're going away from the solution, then within a few minutes, the Rubik's Cube would be ordered. So from billions and billions of years to a few minutes with one simple feedback of information, that gives us a clue about the probabilities of how the biodiversity and the structure of cellular systems and all of our complexity that occur could have come to be. with one simple feedback in the structure of space itself.
Our universe cannot be purely random. There must be a feedback mechanism in the flow of the universe.
So a Rubik's Cube would require longer than the age of the universe to be solved randomly. Forget one little blade of grass with all the biological, bacterial life on it. That is way more complex than a Rubik's Cube. But then even forget that. Let's just try to calculate, this is in one of the papers I've written, let's just try to calculate just like the simple, arrangements that's required for monocellular life, for the first life to emerge, just a simple cell, just one, right? What is the possibility that that would happen randomly, okay? Because that would tell us something, because, you could think like somewhere in the universe, if the probabilities are there that one cell happened and then maybe it propagated unless, the cell happened and then, oops, a rock fell on it. And then it's like, oh, another few trillion years. But let's just say it survived, right? But let's just calculate. So the calculation is pretty straightforward. This is some of the most basic mechanisms that must occur in order for life to emerge, right? So there's RNA positions that are being associated to nucleotides, and they have to match in order to be able to build up from our RNA the fundamental mechanics of life. When you calculate these possibilities of the nucleotide matching, to build that structure, you have a possibility of 100 to the 4,448. Okay? The number is 10 to the 8,896, if I remember well, from the calculation. Okay? 10 multiply, right? So you're adding zeros. 8,000 zeros. Okay? I know you guys are mostly like business people, so you know what happens when you add zeros in your bank account, don't you? Right? It grows fast, right? If you got 5 zeros and you add 1, it's like, whoa, that's better, right? And you got 6, you add 1, it's like, oh, yeah, baby, I like it, right? And then, but imagine, this is the biggest number I've ever seen in all of the physics I've studied over a period of 32 years I've been studying physics, okay? This is a large number. For people that have a hard time, I have a hard time visualizing a number that large, okay? It's big. Just to give you an idea of, to compare, a comparison, each notch on here is 1 billion light years, okay? Light moves fairly fast, right? At about 3 million meters per second, right? So it's pretty quick. Okay, it's 1 in the morning, I'm sorry. And this is a representation of our universe, right? So this little scale gives you an idea of the diameter of our universe. And when you write that in exponents, when you give the log of this, right? When you write that in exponent, the value for centimeters, which are fairly small, right? A centimeter is fairly small. The universe is really, really big. Like the Earth is big, right? The Earth is like a grain of sand beside the sun. If you put the Earth beside the sun, it's like a grain of sand. The sun is like a grain of sand beside most stars. The sun is very small beside most stars, right? Our solar system in the galaxy is, not visible. It's too small. The galaxy is huge. It's got about 200 billion stars in it. You won't see it, right? When you calculate the radius of the universe in centimeters, you'd expect there's a lot of the little suckers, right? There's a lot of centimeters. Well, the value is 10 to the 28 centimeters. That's the radius of our universe, which is huge, 10 to the 28. So the probability that you came alive, the probability that one little sludgy cell happened on this planet, or anywhere else in the universe for that matter, right, exceeds vastly the radius of the universe, right, in terms of probabilities. It's remarkable. So the fact that the little humans on this little planet lost in the corner of this little galaxy are thinking that somehow there was a miracle that only happened here, right? And that miracle produced us is remarkable, right? The concept, the fact that concept even survived for 100 years of physics or 150 years of physics is remarkable. It's remarkable, and I'm sure it's the subject of many conversations across the galaxies, Did you hear what the humans came up with? Oh my God. And why is that? The reason is because there was this great battle between religions and science. And it was critical for the scientists to separate from religion. And if it wasn't random, if it was organized, then somehow there must be a God somewhere. That was the only alternative. And if there was a God, then religions were right back in and just couldn't allow that. So it had to be random. But there's a possibility between there's a God that's organizing everything and it's completely random. There's something in between. That thing in between might be your existence. That thing in between might be the source of your self-organizing incredible miracle of you being here right now. That thing in between may be the fact that information in the universe is non-local. That is, that the system knows about itself, that it has feedback. So, starting from that assumption, you'd have to say, well, then, what is matter? What is the material world, right? If it's like, okay, so let's assume that there's some kind of information feedback that can self-organize. How is it working? Is it in the matter? What is matter? Something like fundamental, you should ask. What the hell is this thing I'm in, right? Why is this solid over here? Why is this solid? What makes it solid? Why does it stay solid? Why is it not falling apart right now? What keeps it that way? What keeps you that way? And then if you start looking closely, you find that matter is made out of these little things we call atoms. And these atoms, they're not so material after all. When we look closely at the atom and we try to figure out what is this thing made of? What are you made of? Oh, atoms. Okay, that's nice, but like, what is that? Like some kind of little billiard ball that's running around down there? What is this atom thing? Well, when we look closely, we find that it's made out of 99.9999999% space. Mostly space. A field, right? And in that space is an electric charge, an electrostatic charge, a really teeny electrostatic charge. So a lot of space with not little billiard balls going around, but an electric charge that makes a little shell in the space. And we've spent most of our lives, we've spent most of our physics, most of our exploration, considering the little electrostatic boundary and not the space. We've ignored the space. You realize you are made of 99.99999% space? That's pretty spacious. You know, spiritual people have a tendency, we hear them all the time saying, you know, it's so dense down here. Wow. It's 99.99999% space, brah. It's mostly space. How dense is that? So that space makes boundaries. So for me, very early on, I realized, wait, maybe it's the space that defines the matter, not the matter that defines the space. I wasn't the first one to come up with something like that. There was some of the greatest physicists on the planet that understood that something like the space of the quantum field, the space of at the quantum level, should be studied. No point is more central than this, that empty space is not empty. It is the seat of some of the most violent physics. That was that was Wheeler, one of the greatest physicists here walking along with Einstein. David Bohm, space is not empty, it is full, a plenum as opposed to a vacuum, and it is the ground of the existence of everything, including yourself. The universe is not separate from this cosmic sea of energy. Einstein himself, one of the best physicists we've seen in history. Physical objects are not in space, but these objects are spatially extended. In this way, the concept empty space loses its meaning. Right? Objects are spatially extended. That is, the structure of space extends itself to produce an object, changes state. The space changes state to produce an object. That is, I'm looking at space here that has become solid because it has acquired a little electrostatic charge. The space in you is not empty, it's full of electromagnetic fields. Now you might say, what is he talking about? On top of it, it's, 130. Like, what is he talking about? Yeah, space is definitely empty. I can tell, right? It's empty. Of course it's empty. Look at the space out there between the sun and the earth. It's empty. But you know that the space between me and you is full of electromagnetic fields. For instance, if you put a radio on the stage here and you tune it to the right frequency, you'll hear the radio station, right? You'll hear the radio station, and it's not because the band is in the little box, right? The band is not in the box. But it's picking up a field, right? It's picking up a field that has information in it. And that field with information, you don't see it. You don't feel it until you tune a little crystal in your little box, and it oscillates just at the right frequency, and all of a sudden you hear the voice of the announcer. You hear, the football game. You hear the music. I work with many scientists around the world, many physicists, biologists, biophysicists, chemists, and so on. Many of them are looking for the seat of consciousness, are looking for consciousness inside the brain. Inside the brain. That would be like looking for the announcer inside the radio set. It's not in there, brah. You can dig all you want. You will not find the person in there. It's just not. It's not because you have sodium, potassium, little exchange between neurons, little electrical discharge, that you have consciousness. It's irrelevant. You can have, I can make little discharge in my laboratory. I have a fairly, equipped laboratory, like all day long, like millions of discharge a second, I can, right? With good equipment. The thing is not gonna all of a sudden walk away from me. It's not gonna all of a sudden solve differential equations. If it could, I'd be so on it, because differential equations sucks, right? Right? So it's like consciousness is not an electrical discharge in your brain. There's a much larger chance that consciousness or the electrical discharge in the brain is actually a secondary effect of information transfer into your biology. From that field of information, from the vacuum. Now, I started talking about the vacuum. This is Einstein tapping into the vacuum with his hair antenna. I started talking about the vacuum in the 90s. Since Einstein and Bohm and Wheeler trying to get the world to look at the vacuum, everybody ignored them, although they were the best, right? Then there was this crazy guy in a van in the 90s, Took a while, right? And then finally in 2018 or 17, I think it was 17, Nobel Prize winner started to talk about it, started to discuss it publicly, had the nerve to talk about the ether, talk about the structure of space being a real thing that we should consider in physics. This is Frank Wilczek, one of the greatest physics and mathematician of our time, right? You can't just remove the atoms, remove the particles, and think that you have nothing now. When you do that, you still have something. In fact, you have a lot of things. A lot.
Put it another way, again, it's vacuum is not void. Void.
Now, I want to ask you
the absence of particles the absence of excitations is not the absence of structure.
Yeah.
The absence of particle is not the absence of structure. This is Nobel Prize winner in physics, a very good mathematician. He's not just talking through his ass, right? Like he's talking from good physics, okay? Just so we're clear, okay? That means, what he just said there, just to translate, that means that you can remove all the particles in this room and you will still have structure. That is, you can still have dynamics. That would mean that there could be beings in the room. You can have all kinds of things in the room, even though you've removed all the material. Right? You guys are following me? That sounds pretty esoteric to me, doesn't it? That sounds a lot like what spiritual people have been talking about for a long time. Okay? I'm wanting for you, if I can transmit anything to you tonight, is that your existence and your reality go way, 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 way beyond the senses that gives you a sense of that reality. Way beyond. And your experience, your consciousness may not be localized inside your body. Okay? Because from what we get now from physics, I can remove all the particles that makes up your body and I still have structure. I still have information. I still have the essence of what information your body was made of. Because as Wilczek tells you, we can't account for the particles without ascribing these values to the space itself. Did you hear him say that? Right? So your information is not the molecules. It's not the atoms. So it's very doubtful that your consciousness is the result of these molecules and these atoms. Right? You know, I prayed for some 20 years that some well-known physicists out there would support me and mention, right, that very statement, but I never in a dream thought that he would literally call us ethereal beings, right? You are an ethereal being. What does that mean to you? That is, you're not a being that is from the physical realm. You are a being that is from an etheric realm. What is this etheric realm? And is the material realm something separate from that ethereal realm? Is it? For me, clearly not. For me, I start to realize very early on, when I was in my van calculating, that like it had to be a continuum. You couldn't separate the two. You couldn't get rid of one. You couldn't get rid of the other. The two are entangled. You cannot. I start to realize that field of information must make the material world that we see as our reality. So you can't separate it. But how could I prove it? It took me a long time. Well, it took me 30 years. It's relatively long. When you study quantum physics, they tell you all sorts of weird shit. It's unbelievable. The first thing they tell you, you know, you've been doing mechanics and you've been doing Einstein field equation and it's all good because it's all mechanical and good. And then you get to quantum theory and the first thing they tell you is don't try to visualize that shit. Just calculate and shut up, right? Don't try to figure it out. It's not anything you can understand. It's just weird shit down there. It's quantum weirdness. Do not attempt in visualizing it. And when you calculate, eventually you get to quantum field theory, and if physicists in general are honest and you talk to them about quantum theory, they'll tell you nobody understands quantum theory. And, well, quantum field theory I'm talking about. And when you get to quantum field theory, you get to this part where you're trying to calculate how the quantum world, now quantas mean that it's quantized, that is, it's in little grain, it's in little quantities of energy, right? So it's not continuous, it's in little packets. You try to calculate the packets of energy that there is in the vacuum, in the structure of space at the quantum scale. You try to calculate that. And when you calculate it, this is a calculation that most professors in university avoid, right? They avoid it because it raises too many questions in the students, right? So when you get down to the nitty-gritty, you find that the vacuum density in the quantum vacuum, it has a density of 10 to the 93 grams per centimeter cube. 10 to the 93 grams, that's 10 with 93 zeros. It's an extremely large number. Just to give you an idea, the mass of the universe is 10 to the 55. Okay, so there's more energy in a centimeter cube of quantum space than all of the stars and galaxies and black holes and everything you see in our universe stuffed into a centimeter cube of space. Okay? That's less energy. That's of what's energy there is. This is like, how many centimeter cube of space are you made of? Many. Right? Many. And each one has this value in it that exceeds the mass of the universe by 39 orders of magnitude. Okay, and this value is not just some like crazy, calculations that's irrelevant, which is what they assume when they found it almost 100 years ago. They said, this is such a large number and we can't deal with this. We're going to make like it's not there. You would think that some physicists would have got, oh my God, we found God, right? It's like, oh, no, we're just going to make like it's not there. This energy is present in every one of the centimeter cube of space that you observe in this room, including your body. And here on Earth, we go to war to find energy. We go to war because we think there's not enough energy on our planet for everybody to have what they need. We drill holes in the ground and we pull out, right, rotten dinosaurs, oil that we refine and put in our cars. Meanwhile, there is 10 to the 93 grams per centimeter cube of space, of energy. Okay? This is a lot. Now, one calculation I did early on is like, okay, let's check it out. Let's take the nucleus of an atom. It's a teeny thing, a nucleus of an atom. You're made out of 100 trillion cells, right? Cells are small because 100 trillion of them are in your body, right? The cells themselves are made of atoms. There's 100 trillion atoms in each cell. So that's 100 trillion multiplied by 100 trillion is the amount of atoms that makes up your body right now. So atoms are really dang small. And in the middle of the atom is a little proton, is a little dot. And that little dot, okay, has a little volume, it has a little radius. And I took that radius and I calculated its volume. Its volume is 10 to the minus 39 centimeter. It's very teeny. And then I calculated how many of these little quantas, they're called Planck oscillating oscillators, or I call them PSU, Planck units. And I calculated how many there is. And it happens that in every one of those protons, there is 10 to the 55 grams of little Planck oscillators, of little Planck spherical units. 10 to the 55 grams. That happens to be the mass of the universe. So that means, remember, mass is equivalent to energy, E equals mc squared, and energy, as I told you, is equivalent to information. That means that all the information of all the other matter in the universe, of all the other protons, of all the other beings, of all the other things that exist in the universe is inside each one of your protons. Okay? This is called a holographic principle. In a hologram, each point contains all the information. That's why you can keep cutting it in smaller pieces and get, all the information. There's entropy, so you lose a little, but... So, what does that tell you? That tells you that literally through every one of your atoms, I can find, through every one of your atoms, you can find all the information available in the universe. All the energy available in the universe. Through each one of your protons, through each one of your atoms. But those are not outside you, those are inside you. So if you're looking outside for the information, you might just miss it, right? Because outside, you have very little capacity to reach, right? You can only reach that far, you can only see that far, you can only feel that far, so on. But inside you, you have all the information embedded in every one of your atoms. This is non-trivial. Now, if I told you just this as philosophy, it's nice, but it's still just philosophy. It doesn't do us any good in terms of understanding the physical world, in terms of, developing technology that can tap into that shit. Because if you tap into that field of energy, even in 1 centimeter cube of space, if you just got 1/10000000% of the energy that's there, you could run the whole planet for thousands of years. The whole planet for thousands of years. Right? So it'd be useful to understand how this little energy works, right? If you could figure that out, not only would you have all the energy you need, but you would actually understand the source of your existence. So I went for it. I'm that kind of guy. But you gotta understand a little bit of the scales. The scales that I'm talking to you about for these little quantas of energy are remarkably different than the scale of our existence, right? If I take one of those little Planck oscillator and I made it the size of a grain of sand, then the proton would have a diameter of 40 trillion kilometers, the distance between the sun and Alpha Centauri. Okay? So this is the scale difference between this field of information, right? This field of high density, as Wheeler said it, this field of violent physics that's occurring and you. So of course, you don't experience it directly. When I tell people the vacuum is full of energy, people say, well, why can't I feel it? Well, it's not happening at your scale, right? Imagine a proton the size of a bubble between the sun and Alpha Centauri, 40 trillion kilometers in diameter. Imagine the little oscillators are sand in that bubble. They're, you know, to you it would look solid. You wouldn't see the sand, right? You wouldn't know it's there. Would that make, you guys see what I'm saying? So if I made a proton out of that sand, you wouldn't know that the proton is made of it. You would have no clue. You see the dilemma? You see the problem? So this is what I concluded eventually. So I started to count the sand in the little proton, okay? And I'm telling you this in really like a simple way and a direct way. It took me 20 years to count the sand, to get to the idea of counting the sand in the proton, right? All kinds of complex equations that I'm gonna save you the details of. But eventually I realized that if I count the surface amount of these little Planck, and I count the inside amount, and because of what I had done, I realized that the surface information, right? So think of all this information that's inside the proton. Why are you not having access to it? Right? Why are you not directly accessing it? Well, because there's a surface. And that surface restricts how many of these little bits of information can be exchanged. So it occurred to me that maybe the exchange of what's going on inside and what's on the surface defines the energy level of the system. It's a straightforward entropic description. And I calculated it, and it gave me the exact value for the mass of the proton. It was correct. Like, what are the probability that it would be correct? I'm actually dividing numbers that involves the mass of the universe, right? I'm dividing numbers that involves the mass of the universe, and by the time I'm done by dividing these numbers, I get a mass that's 10 to the minus 24, which is the mass of the proton. And it's exact, right? It's exact. What are the probabilities that that would be true? If I was wrong by just, if this concept was wrong by just a little bit, it would be orders of magnitude wrong when it comes out that number, right? So I continued to do the exploration. This was this paper that I published that, you know, got me so many rotten tomatoes. The equation gives a direct value as well for the radius of the system. So I calculated that radius, and I got a value that was very strange. It gave an exact value for the mass, but for the radius, it gave me a value that was 4% smaller than what's predicted by the standard model in quantum theory. So 4% might not sound like much to you, but in quantum theory, calculations are usually done with accuracy with 10 to the minus 10, 10 to the minus 11, 10 to the minus 12 digit of accuracy, like 12 digit after the period accuracy, right? So 4% is like you're wrong and you're in another universe, right? You're vastly wrong, right? But my calculations in this paper give as well all kinds of other values, constant, that were exact. So I just couldn't ignore that. And so I published a paper making a prediction that we had badly measured the radius of the proton. And I put it out there in 2012, December 21st, 2012, by some coincidence, the end of the Mayan calendar. And unbeknown to me, in Switzerland, in an accelerator, they were trying to calculate the radius of the proton more precisely than ever before. And when they did, they got a value that was too small by 4%. And the value they got was within 0.00036 of my value. I was inside the margin of error of their accelerator, so in fact, my value was correct, and they were off by 0.0036, right? This value is the kind of thing that happen in science and physics that changes the face of physics. When, you know, just to make clear, like for instance, in 3 decades of string theory and billions of dollars spent and thousands of physicists involved, not one value in string theory has been successfully predicted or, you know, verified. In this case, it was verified literally months after I published. So that was exciting. But the measurement was done with muons, and, you know, it took a lot of time for the physics community to accept that value, and eventually it became the co-data value. In 2018, they made that value the official value for the radius of the proton. And in the same step, confirmed that the theory is correct, right? I, of course, during that time, continued to explore the theory and applied it to the electron. And I got the right value for the electron as well. The mass, the radius, it all came out. All of a sudden, I was accounting for the mass of the universe, which is protons, and the charge of the universe, which is electrons, right? Right out of this field of information. Right out of information fluctuating in a field of electromagnetic oscillation that organizes. Think of it as like this smoothie of, you know, when you do your smoothie, you get these little bits, right? And they fly around and they spin in the thing. Think of the smoothie universe, like wherever there's an atom, there's a little smoothie going on, okay? And all the bits in that region are spinning in a coherent manner, and when it does that, the space becomes solid, right? But over here, it's not spinning like this. It's not coherent. It's oscillating, but it's not coherent. But over here, it's coherent, so that's an atom. It's a particle. You see it. It has a charge. You see what I'm saying? So, and then these coherent things come together. They make larger things. So then I continue with my equation and say, oh, can I get larger things? And I went right up to the universe, and I solved the same equation for our universe. And I'm going to spare you the details, but what happened is when I solved it, you see this is the volume to surface ratio divided by 1 over the volume of the universe for the density of this energy in the universe, which gives me the critical density of the universe, this value. Why is this? First of all, it's remarkable. I just took an equation that was giving me exact values for subatomic particles, for very, very small things, and I just blew it to the universe. And I get the right value for the universe, but not just approximately, exactly the right value. That is the critical mass, which is the mass of the universe plus dark matter and dark energy, which is a fudge factor that in the standard equations they had to add in because they're missing 96% the mass of the universe in their equation. In my equation gives the right value. Why is that? Because the universe is made of this vacuum energy, and my equation calculates that, right? So of course, it gives the right value. It would be like you're trying to calculate the mass of what's going on in your coffee when you put the milk, right? You spin your coffee in the morning, right? And if it's a black coffee, I think with Tony, you're not allowed to drink coffee. Is that right? Anyway, it's a black coffee. I don't know. I mean, if Tony drank coffee, I don't know what would happen. It could be like a nuclear event, right? If you take that black coffee and you spin it, you take the spoon out, you can't tell it's spinning, can you? Right? If it's a good black coffee, you can't tell it's spinning. Then you put the milk in it, and all of a sudden it makes a little galaxy, right? It's like they considered the milk and calculated the mass of the milk, but ignored the coffee, right? A galaxy is the spin of this vacuum energy in a region of space. The stars in it and the dust in it and all the stuff in it, that is the stuff that's stuck in the spin. If you only take the stars and the dust, you're missing 90% the mass of that thing, because you got to calculate the mass of the field, right? So you see, this is a whole different picture of reality. All of a sudden, the field is the only thing that exists. It's not even that you're not your body, that you're not your mind, that you're something else. It's that something else, that field, is the source of your body and your mind, right? It's a continuum. It's not a separation. It's that the source is not the body. The body is the result of the dynamic of that source. So, you know, this is all beautiful and nice and dandy, but it takes a lot to convince physicists. And, you know, changing the world of physics is not easy. But changing concepts in our understanding of our reality is critical. It's critical to our survival today, at this time, in our world, in this particular situation that we're in. It is critical that we understand these principles. For each individual to be able to understand their existence, the source of their existence, the source and their power. Not, you know, your non-trivial event, my friend. You are non-trivial event. There is not much more miracle than you. And the energy that you contain is seriously non-trivial. Although at this time of the night, that might seem to be petering, right? There is more in there. And it's not disorganized, it's highly organized. It's highly coherent. It's dividing 1 million cells every second, right? And it's continuously remaking you. You're not the same person you were 3 weeks ago. Within a few months, you pretty well shed all the shit you had then, and you got all new shit. Like you're remaking yourself every few months. Most of your body is remade every few months. Your skin every few days, right? And so this is highly coherent behavior. And so if it's coherent behavior, then it must have very coherent way of division. And I continue to explore this. I'm going to spare you the details. But I started to, this is brand new. This is unpublished. This is what I was planning on showing you. But I know it's late, so I'm not going to go into much details. But this is remarkable. This is data of hundreds of thousands of objects in the universe based on my equation. And when you run the data based on these equations, all of a sudden you see the pattern appearing. This is atoms. So this is the nuclei of atoms. These are electrons. These are planets in the universe, right? All the planets we've discovered. This is stars in the universe. This is galaxies. There's 20,000 galaxies in there, or 100,000 galaxies in there. Clusters of galaxies, and this is the universe. So you can see it's organizing, and you can see that when you get to the universal size, it's not finished growing. It's still learning. We live in a young universe. Well, actually, teenage kind of universe, right? And you can see from these equations that all of a sudden you can develop a set of mathematics that will give you values for the age of the universe, for instance. And when you compare these values to the data that has been gathered, our value is exactly in the means of everything they've been measuring. The probabilities for, it's important to understand the probabilities that that would be true is extremely low, okay? And so we developed these mathematics, these scaling factors. It's like the field is not only highly energetic, it's fractalized. It's like geometry fractalizing from one scale to the other. And we developed these mathematics, we developed these scaling factors to see how it fractalizes. And we got all the right values for the subatomic particles, for the atomic particles, for stars, for galaxies, and for the universe size objects. And life happens to be right in the middle, smack in the middle of the scale, right? Exactly where you would expect it based on these equations. So you are the antenna that's connecting the infinitely big with the infinitely small within yourself. You are that oscillating information transfer set that's informing the universe about your reality. About you are evolving the universe across all scales. What are you telling the universe, right? You have a very fundamental, deep responsibility about what you're telling the universe. Because remember, it's a feedback. So whatever you tell the universe will manifest for you, right? The field will manifest whatever you tell it to a certain extent. Because the field is not only in contact with you, it's in contact with every other antenna in the universe, right? Which is every other proton. So it's a correlation of all the realities that makes up the agreed reality of our universe, right? So it's not just you. You are not the only one that's making reality. Reality is making you too. It's a feedback, feed-forward thing. So that's really important to remember because it's a collective experience. It's a unified experience. You are unified with the rest of the universe. The illusion of separation. So it's just like this. It's just like this. You have this amazing set of information that is producing more and more material and agglomerating more and more material and getting more and more complex, making stars and then eventually planets, and then the surface of planets starting to make microbes and all this stuff. It's making very complex things, and it's adding complexity, and more information can move through the network, and then eventually it makes a thing that's a human being. Right? And that human being is getting so much feedback information through its system because it's complex enough that it becomes self-aware, because feedback, right? Self-awareness is feedback. It becomes self-aware, and in that moment, there's the greatest danger. In that moment, that being all of a sudden can think that it's separate from the very thing that created it. That being in that moment of awareness can think, I'm separate from this world. And not realize that it's part of that feedback. And it will need to evolve and eventually realize the physics of the universe to realize its relationship. Because philosophies will not do the job. Philosophies can point the finger. Spirituality can point the finger. Spirituality is just a physics we haven't understood yet. It's wonderful, right? And it's been there for a very long time. But if you're going to evolve your civilization so that you have infinite amount of energy, so that you can go across the universe, so that you can go across the galaxy, so that you're not plugged into a nuclear power plant or plugged into a diesel burning energy plant, and you're not destroying your environment and all this. If you're going to evolve beyond that, if your society is going to make it, it's because it has figured out how to tap into the source of the universe so that it aligns its technology with the fundamental forces of creation. Right? So it's critical that it goes beyond the philosophy and into the understanding of the mathematics of the physics in which it really happens. It's not that the philosophies are wrong, it's just that it's not been described in a formal mathematical way that we can apply to engineering and technology. As well for your brain. It's important that you know that it's not just a concept, that it's really the way things are. When a guru tells you it's all one, it's kind of nice, but it's like, how? Right? It's like, okay, I'm just not feeling one with this table right now, and my brother is really pissing me off. I don't think I'm one with my brother right now at all, right? I mean, I have two boys, so I know I deal with that every day. I continued the exploration. I just wanted to throw this in because this slide here shows that you can use the same equation to go beyond the PSU, beyond the Planck oscillator, because of course, there's no reason why the universe would stop at one specific grain size. There's absolutely no reason. That grain size must be made out of smaller grain size, which is made of smaller grain size, and so on. It's just a question of our capacity to measure. And since we can measure above that grain size and we know the equation is correct, then we know that this is correct as well. And when I got this, I wanted to show you this because I thought it was remarkable. Because that grain size here is clearly the speed of light. That is, the mathematics that gives us that grain size is tied to the speed of light. Okay? It's basically how long it takes a little photon to go across itself. Right? Well, if you go below, that means you're going faster than the speed of light, right? You're going supernuminous. And how fast are you going? You're going 10 to the 40th time faster than the speed of light. So it's pretty fast. This is the speed of thought of the universe. This is how fast, this is why in a laboratory in quantum physics, we see particles entangle themselves. Where when you move one particle, the other one moves instantaneously, no matter how far it is from each other. At this speed, we would think of it as instantaneous. For us, it would look instantaneous. To give you an idea, at the speed of light, crossing the universe takes billions of years, right? So light is actually pretty slow relative to the size of our universe. At this speed, it takes 10 to the minus 23 seconds to go across the universe, okay? It's almost instantaneous to go across the universe. This is the speed of thoughts. This is how the grain of information moves through your body. This is how, from your experience, you're updating the universe instantaneously. The whole thing is entangled. Every particle in the universe is in contact with every other particle, right? So from this value, and again, I'm going to spare you the details, we were able to output for the first time in history an analytical solution to the gravitational constant. We have never had that. We've never had, we measure the gravity, we know the acceleration of gravity, we can measure it on the surface of the earth and so on, but we have no physical description, right? Analytical description, computational description of gravity. For the first time, we were able to output it. And we output it directly out of this vacuum structure. A Russian attempted it in the 60s, and he came up with this, which was very close but unsolvable. And using our equation, it was easily solvable. So we outputted the value for G, and as we outputted the value for G, all the other constants in physics started to emerge. I will always remember that moment. We were writing equations with Olivier, a French physicist that I work with, on these whiteboards, and we were running out of whiteboards, and we were so in, the moment of and the flow of the little particles was going so well that I said, let's just keep writing on the windows. And we continue in my office writing on the windows these equations. And all of a sudden, the light shined through. And we arrived to this moment, and we saw all of the fundamental constants in physics emerge. And it was like the angels were singing, my eyes watered, and it was an amazing moment. It's an accomplishment, of a lifetime, and I really felt the sensation, the literal sensation of these fundamental constants, of these fundamental mechanics inside my body. Not just in a conceptual notion, I felt my body change as I understood what was coming on, what these equations were telling us. It was remarkable. Thank you. Thank you. And so I continued to explore this, and eventually I got all of these constants as a result to emerge with precision that is unrivaled today, right? We have, precisions with 10 to the minus 13 digits of accuracy, 13 digits after the period, on constants that were only known to 10 to the minus 5. how can we, know that we have the right numbers after 5 numbers? Because the same equation gives us all the other constants. And some of these constants are measured to 10 to the minus 13, right? Like the G factor, like the Rydberg constant, and so on. And so since all of a sudden, you see in physics, the constants are currently just plucked out there, they're unrelated, right? The gravitational constant is not related to the Rydberg constant, it's not related to alpha, it's not, all these things are not related. All of a sudden, they're all related through this field of information, through these equations. All of a sudden, they all updated to 10 to the minus 13 digit accuracy. The whole thing, bam. All of physics just took a huge step forward, right? And I continued to study, these constant, and eventually, of course, the forces came into action, the 4 forces of nature. And it turns out that the 4 forces, like gravity, electromagnetism, the strong and weak force, are just fluid behavior of this information moving through the event horizons, right? Think of, you have an event horizon, think of like the surface of a sphere, right? Like the surface of a black hole, and think of the information moving through the surface. Well, when it moves through, we call it gravity. And when it gets really close to a proton, really close, something really small, then we call it the strong force, right? The force that holds the protons together, like a pressure on the surface of an event horizon. And then imagine the information that's moving through is creating information moving out, right? There's an exchange, there's a feedback. While the information moving out is what we call the weak force and electromagnetic force. It's the radiative force. So it's like a flow of information. We mathematically describe that flow when we found the forces, right? So we can actually understand these forces at their most fundamental level, which allows us to derive devices that eventually can produce that flow artificially. We can make the flow in a laboratory. What will that give us? Well, it'll give us access to infinite amount of electromagnetic radiation, which is really good for energy production, right? But as well, it will give us the capacity to control gravitational fields. We will be able to make gravitational fields artificially in a laboratory and eventually in a spaceship so that we control gravity. We built a whole society because we have learned to control electromagnetic field. That gives us all of our devices, all of our modern life. The next step for humanity is to learn to control gravity. And in order to do that, we had to have an analytical solution to the gravitational constants. Now we have it, so now we can get there. That will change everything in the world. This changes all the SI units, but this is, it's really important to a physicist, but it's trivial for us right now. So of course you can build technology out of this, and I have modest means in my laboratory, so I have started building technology out of it over the last 20 years, but of course this is bleeding edge physics. This new paper I haven't published, I will publish soon, will help me. But physics costs a lot to experiment with, right? It's like experiments, laboratories are expensive. So funding that kind of stuff is really tough, although the outcome is critical for humanity. You wouldn't believe how hard it is to finance a space drive, gravitational space drive on this planet. Most people look at you like, what are you talking about, right? So, but it's critical for our survival. So I have been working on it. I've succeeded in creating little coherency in the structure of the vacuum locally, okay, using crystals. And I've been able to show the effect of these crystals. It's very little effect, but it's significant. And eventually these little crystals will run your car, it will run your house, it will run your spaceship. It will get there. But I'm doing the best I can with what I got. And so I've made those little crystals, and they're based on, of course, you know, I use crystals because they're good oscillators. That's why they're all in our electromagnetic devices, right? And they are highly coherent. And the geometry of the crystal molecule, the reason they're so good oscillators is because the geometry of the molecule matches nicely to the geometry of this fundamental field. Of course, if the field is building material, it's going to build the material, right, based on the same geometry. So that's why the water molecule is a tetrahedron. That's why, you know, the crystal molecules are tetrahedral. And so, you know, I use this fundamental concept of this smoothie universe with tetrahedral geometry, and I built a device that reproduce these dynamics in a local environment. It's a complex device, but actually not that complex. Here you see it, right? It's inside a copper room, a very special room, and it spins the electromagnetic field at very high velocities, millions of RPMs, and it creates a little smoothie in the structure of space. And when I put crystals in that smoothie, the crystal are imbued with that entrainment of the structure of space. And they continue to make that little vortex in space after I remove it continuously for years. The first crystals I made were in 1999, and they're still as active today as they were then, because there's very little entropy in the vacuum of space, right? The structure of space is like a superfluid. So when you get it going, it keeps going. In fact, the device runs even without power, meaning when it's off, we can still measure an electromagnetic vortex in there. So, you know, I made these little crystals. It took me until 2017 before I could make them in large enough quantities that I could put them on the market. And I put them on the market. I'm going fast because I know you guys need some sleep. But I put them on the market because what I noticed in these little devices, this is a test we did in France. Just so you see that, like, so this is the charge one. So look at this meter here. You can see it's pegging, right? This is one that's not been treated. You can see it actually loses energy, right? The impedance go up. He's going to put it back, the charge one. You can see, right? It continuously outputs power, right? So, and that power is coherent power. It's not like cell phone power that kind of produce incoherence in cells. And that makes things grow faster. I'm going to speak, I had a little movie of things growing. I'm just going to get to the point. So, we made devices in which the water can run through the crystals, right, to see if we can energize water and what it does to plants. And you can see these are the plants that got the water that went through the tetrahelix. These are the ones that didn't. They're in very harsh environment, you can see. Well, you know, we stress them so to see if the water has a real effect. But I think this is really kind of telling. This is a tomato test, for instance. We've done thousands and thousands of tests, by the way. It's not like just one test here and there, okay? Thousands of tests. So here is the crystals, and these tomatoes were grown with that tetrahelix device. Andrea, if you want to bring the tetrahelix up front. And then this is the control. This is after 7 days. This is after 300 days. Okay? The water, of course, in the control is completely evaporated, right? After 300 days, these tomatoes are in a warehouse. It's hot in there. It's not under air condition. Of course, all the water. This is the device, right? It's a nice little device. And actually, if you're sensitive, if you put your hand in front of it, you can try it after. You'll feel it. It's non-trivial. And anyway, so this is, you can see there's still moisture in them after 300 days. This is 365 days, so this is a year-old tomato, okay? Yes, they're not looking as good as they were when we picked them, but there's still water in them. There's still moisture in the water, in those tomatoes, because the water has such a high energy level that the structure in the water makes it very difficult for the water to evaporate, but as well, it makes the water very highly bioavailable, so it can stay inside the cell, no matter what. I mean, 300 days, you see? These are still like that since, you know. I'm sorry? Yes, I drink that water every day. That's why, you know, I'm 150, but, you know. So, you know, this is a second test we're doing. Actually, it's current, right? So this is these are tomatoes that were not grown with arc water. It's just normal tomatoes we got from the market. So just by putting the crystals in the vicinity of the tomatoes, this is the control. You can see that the ones that have the little crystals in the middle are doing much better. We've buried in there 8 little crystals on a big, you know, wheatgrass growth area, and you can see how the concentration is in the growth in the middle there, you know, where the crystals have been buried. And it produces rings, you know, multiple rings, because what we've done is actually affected the structure of space-time. Space-time is creating the little smoothie of coherency in that region. You can think of it as like throwing pebbles in a pond and making those rings, right? So it's ringing in that region of space-time, and it's affecting biology positively, right? In that region. So those are very big evidence that it's working. Of course, we work on applying that to magnetic motors for energy production, and we will get there. We need help. If you know anybody that can help, we need help, but we will get there. We're getting very, very close. And actually, you know, yes, let's just leave it at that, right? So that you could have a Tesla without batteries, right? It's just running directly on the structure of space, and you never have to charge it, right? You just buy it, drive it, right? You never have to charge it. Electric motors can go for a very long time. You could keep it for 50 years. You'll never have to do anything to it either than drive it, right? Change the tires, change a few bearings here and there, but that's about it. So that's on the way. And of course, the goal of the operation is eventually to get to gravity control. I got good results on that front as well. This is an experiment we're doing. So in the case of gravity control, I got to spin things faster than I can spin a magnetic motor, right? I got to spin things in the millions of RPM to create that singularity, to create the effect at a much stronger than the crystals are able to. So I spin plasma at millions of RPMs. This is one of those experiments where I'm starting to produce singularity. And when I get singularity, then we're done, right? We have gravity control, and this will run your spaceship. It will run your world. When we get there, and we're getting really close, and it's not just me, there's many laboratories around the world on that track, it's becoming clearer and clearer to the scientific community that this field of information or this field is the fundamental field of creation, and that we need to learn to tap into it. So that was it for me. Thank you.